All right, so today we are going to talk about some special relationships that exist between arcs and chords. We've got three properties that we're going to be looking at today. The first one says if I have a diameter or a radius of a circle that is perpendicular to a chord, so makes a right angle with a chord, then that diameter or radius is bisecting the chord and its arc. What does bisect mean? To cut it in half. So it cuts the chord and the arc in half. There's our first property. Second property, two minor arcs are congruent if and only if the corresponding chords are congruent. So if I have two arcs and I know they're congruent, then the chords that connect the endpoints would also be congruent. If I have two chords that are congruent, then the arcs that have the same endpoints as those chords are also congruent. And then the third property, which we probably won't have a chance to actually investigate until tomorrow, two chords are congruent if and only if they are equidistant from the center. What does equidistant mean? Equal distance. So if I have two chords that are the same distance away from the center, then those two chords are the same size as each other. All right. Let's see what we can do with this now. For the first two problems, number one, parts A and B, number two, parts A and B, we're going to be looking at this second property right here. Two minor arcs are congruent if and only if the corresponding chords are congruent. So if two arcs are congruent, the two chords are congruent. If two chords are congruent, then the two minor arcs are congruent. Let's look at number one, part A. Number one says use congruent arcs to find arc measures. Part A says that segment JK, which is a chord, this one right here, segment JK, and segment LM, which is another chord right here, are congruent to each other. Well, if those two chords are congruent to each other, what would that mean about arc JK and arc LM? They are also congruent to each other. So I'm going to mark that on my picture. I'm going to put two little congruence marks on those arcs. And we have arc JK congruent to arc LM. So that means the measure of arc JK is equal to the measure of arc LM. How big is arc LM? 75 degrees. So how big is arc JK? 75 degrees. The measure of arc JK is exactly the same size as LM. So it would have to be 75 degrees. I'm going to add that on my picture right here. So far, so good? All right, let's go look at part B. Part B is very similar. It says that segments AB and CD are congruent. AB is a chord right here, and it has a congruence mark on it. It is congruent to chord CD down here, which also has a congruence mark on it. If those two chords are congruent, what does that mean about arc AB and arc CD? They are the same size, yes. So arc AB is congruent to arc CD. So that means the measurement of arc AB is equal to the measurement of arc CD. How big is arc AB? 60 degrees. So how big is arc CD? Also 60 degrees. So I'm going to add that to my picture also. This down here is 60 degrees. Beautiful. Beautiful, beautiful. All right, let's look at number 2. In number 1, both parts A and B, they told me about chords being congruent. Are they telling me about chords being congruent down in number 2, part A? Are they still telling us about chords? What's this symbol right here mean? Arc. So what are they telling us is congruent? Arc DE and arc FG. So remember, an arc is like the crust on a pizza. So this piece of crust, DE, is the same size as this piece of crust over here, FG. If those two arcs are the same size, what does that mean about chords, DE and FG? They are congruent, yes. So let's mark those with some congruence marks. Segment DE, which is a chord, is congruent to segment FG, which is also a chord. So the length of segment DE is equal to the length of segment FG. How big is segment DE according to the picture? 2x plus 6. So I'm going to substitute that in. 2x plus 6 equals, what do they give us for the size of FG? 5x minus 9, yes. And now we're going to solve this for x. So the first thing I'm going to do is get my x's to the same side. So I'm going to minus 2x from both sides. So that would give me 6 equals 3x minus 9. Then I'm going to add 9 to both sides. What is 6 plus 9? 15. So I have 15 equals 3x. And then I'm going to divide both sides by 3, and that means x is how big? X is 5. Is that what they asked me to find in this problem? No. Did I need to find that? Yes. What did they ask us to find? They asked us to find the length of segment FG. Well, the length of segment FG, according to the picture, is 5x minus 9. And we just figured out that x is how big? 5. So I have 5 times 5 minus 9. What is 5 times 5? So I have 25 minus 9. And what is 25 minus 9? 16. So FG is 16. Beautiful. Let's go look at part B. Did you have it for me, dear? Right here. What do they tell us about this picture? Arc RS is congruent to arc TV. So from here around this crust piece is congruent to from here around this piece of crust right here. So what does that mean about segments RS and TV? They are congruent, yes. Segment RS, which is a chord, is congruent to segment TV, which is also a chord. So the length of RS is equal to the length of TV. What are we going to put in for the length of RS? 5x minus 9 is equal to, what are we going to put in for the length of TV? 2x plus 3, absolutely. Now we're going to solve this for x, so I'm going to minus 2x from both sides. That gives me 3x minus 9 equals 3. Then we're going to add 9 to both sides. What is 3 plus 9? 12, so 3x equals 12. And then we divide both sides by 3, and that means x is what? X is 4. Is that what we were asked to find? No, what were we asked for? RS. Well, according to this figure, RS was 5x minus 9. So RS would be equal to 5 times what? 5 times 4 minus 9. What is 5 times 4? 20. So I have 20 minus 9. And what is 20 minus 9? 11. So chord RS has a length of 11. Any questions so far? All right. If nobody has any questions, let's go down and look at numbers 3 and 4. So number 3 says use properties of perpendicular chords to solve the following problems. So I'm going to come back over here. Perpendicular chords. Only one of these 3 properties said anything about perpendicular, right? Just that first one. It says if a diameter or a radius of a circle is perpendicular to a chord, makes a right angle with a chord, then it bisects the chord and its arc. It cuts the arc and the chord in half. So let's go back and look at number 3. What part of a circle would we call DF? A radius. And what is that radius doing with chord EG right here at H? Yes, it's bisecting it because what symbol do you see right here? Right angle mark. So that means it's bisecting my chord. So EH and HG would be the same size. We know how big EH is. How big is EH? 3.5. So how big would HG be? That would also be 3.5. One of the things they ask us for is the length of EG. EG is this whole chord from E all the way over to G. How could I find that size? We're going to add those two together, or we're going to multiply 3.5 times 2. You could do 3.5 plus 3.5, or 3.5 times 2. And what would you get? 7. So the length of the chord is 7. That radius isn't only bisecting my chord. It's also bisecting what? Look up at that first bullet point again if you need to. It's not just bisecting chord EG. It's also bisecting my arc. So from E all the way around over here to G, that's being cut in half right here at F. So that means that arc EF and arc FG are the same size. Do they tell us anything about that size? Yeah, we have arc EFG is 120 degrees. So from E past F all the way over here to G is 120 degrees. Well, if that's true, How big is just arc FG? 60. Tell me what you did to get that. Yep, we're going to take that 120 degrees and we are going to cut that in half. So the measurement of arc FG is 60 degrees. Very nicely done. Let's look at part B. Part B is very similar. What would we call this segment right here? What part of the circle is that? It's a diameter. Goes from edge to edge, crust to crust, through the center. That is a diameter. And what's happening right here at T? What's happening right here? Yeah, it's making a right angle, so it's bisecting my chord. My chord PR is being cut into 2 equal parts. Do I know how big any of those parts are? I know that from T to R is how big? 6. So how big is from P to T? 6. So if that's the case, how big is it from P to R? 12. We would do 2 times 6. So from P to R is 12. All right, that's one of the things they asked me to find. That's this piece right here. We still need to find arc PQ. So I want this arc here. What did they give me to work with to try to figure out that arc? I wouldn't say right angle because it's talking about an arc. It is 90, which we normally say is a right angle, but because it's an arc, we don't call it a right angle there. We just say it's 90 degrees. But I love that you brought that up. Because arcs we measure in degrees just like angles, but we don't have right arcs. So from P past Q all the way over here to R is 90 degrees. What is that diameter doing to that arc? Cutting it in half, it's bisecting it. So if I wanted just the measurement of arc PQ, what would I need to do to figure that out? Divide by 2. I need half of 90 degrees. What is half of 90 degrees? 45. So the measurement of arc PQ is 45 degrees. Absolutely beautiful work so far, yes. Nope. Nope. I'm writing down the work now so that we know where these numbers are coming from. But no, if you can look at that and you can say, well, it tells me that TR is 6, so I know PR is 12. I'm fine if you just write down PR equals 12. Perfectly fine. All right, let's look at number 4. We are supposed to find the value of x here. And when it says find the value of x, they're talking about this x down here in 6x minus 20, not this x here, which is a point. I noticed that it says that chord ZY and chord XY are congruent. So if those two chords are congruent, what does that mean about arc ZY and arc XY? They are also congruent. So how big is arc XY then? 6x minus 20. Now, writing that down didn't help me find x, but do I know measurements for all the arcs now all the way around this circle? Yes, and I know that if I add all of the arcs all the way around a circle together, it's going to add up to how much? It's going to add up to 360 degrees. All right, so we have arc ZY plus arc XY plus arc XZ, and that adds up to 360 degrees. Arc ZY is 6x minus 20. How big did we say arc XY was? 6x minus 20. How big is arc XZ? 76. When I add all of that together, we get 360. So let's combine our like terms. I have 6x and 6x. That'll combine to give me what? 12x. Then we combine the things that don't have x's. I have negative 20, and positive 76. 36 equals 360. Then I subtract 36 from both sides. What is 360 minus 36? 324. 12x equals 324. Then we divide both sides by 12. And we get that x is how big? X is 27. Nice job. We are going to flip over to page 6 now. All right. Let's flip this over. In circle E, diameter CD is 12 inches long. If the diameter is 12 inches, how big is the radius? 6 inches. I see a couple of radii drawn in this picture. CE is a radius, so that would be 6. What else is a radius in this picture? ED is a radius. Anything else? Not GE. EF. Remember, in order to be a radius, it has to go from the center to the crust of the pizza. So it's got to go all the way. So E is the center, but G isn't on the crust of the pizza. That would be like on a cut edge where you got some pepperoni or cheese or something. It also tells us here that chord FH is 10 inches. What is my diameter doing to chord FH? Bisecting it. So how big is each part? 5. What do they want us to find? They want us to find EG. EG is this little piece of segment right here. We don't have a formal name for it. It's like part of a radius. It's part of the diameter, but I don't have a name for that particular piece. It's just that little segment there. I want you guys to look carefully at this. What did I just highlight in yellow? A right triangle. We got a right angle over here, so that would be a right angle over here. How many sides of that right triangle do we know? 2. What have we been using to find missing sides on right triangles? Pythagorean theorem. A squared plus b squared equals c squared. What part of the right triangle has to go in for C? 6, because 6 is the hypotenuse. Yes, the hypotenuse has to go in for C, and our hypotenuse here is 6. The 5 is one of the legs. That has to go in for either A or B. It doesn't matter which one you put it in for. I'm going to put it in for A. So here's my hypotenuse, 6. Here's my leg that's 5. The other leg of that right triangle is EG, which is the thing I'm looking for. So 5 squared would give me 25 plus EG squared equals, what's 6 squared? 36. Then we subtract 25 from both sides. What is 36 minus 25? 11. So EG squared is equal to 11. Take a square root of both sides. On the left, that'll make the squared and square root cancel out, leaving me just EG. So EG is the square root of 11 in its exact form, what would that be in decimal form? What is the square root of 11? Yes, 3.31, and then 3.316 or 3.317, I would take either one. And because we had units on our other measurements, we are going to put units on this too, inches. Nicely done. All right, I want to look at a couple other problems that are very similar to this one right here. They're going to require us to think just a little bit harder, but it's the exact same idea as what we did in number 5. Let's look down at number 6. Number 6, it says that dB is 17. When I look over in the picture, this is dB. What part of the circle would we call that? From D to B would be what? That's a radius, yes. And then it says CA is 16. What part of the circle is CA? That's a chord. What is the radius doing to that chord? It's bisecting it. So how big is each part? 8. So this part here is 8. This part over here is 8. What do they want us to find? AE, DE, and EB. Didn't we find one of those already? AE, how big is AE? 8. AE is half of 16, so AE is 8. All right. Now we want DE. Is DE a whole radius? No. DE is just this part of the radius. And what do you notice right here at E? A right angle. If I could have a right triangle, could I solve this? If I could have a right triangle and I knew 2 of the sides, could I solve it? Then yes. Okay. We said that dB was a what? That's a radius. If I drew a radius in over here, how big would that be? 17, right? What about if I drew a radius in here? 17. What about if I drew a radius right here? 17. And if I draw the radius right here, what does that have me creating? A right triangle. So now I can use what to find dB? I can use Pythagorean theorem. A squared plus B squared equals C squared. What would have to go in for C? 17, because it is the hypotenuse, yes. In for either A or B, we're going to put the 8. Again, it doesn't matter whether you put it in for A or B. So 8 squared plus DE squared equals 17 squared. I know 8 squared is 64. What is 17 squared? 289. And then I'm going to subtract 64 from both sides. What is 289 minus 64? 225. So DE squared equals 225. Then we do a square root of both sides. Over on the left, that lets me cancel out my squared and square root. So how big is DE? 15. This one came out nice and pretty. That means that was a Pythagorean triple. DE is 15. I'm going to add that to my picture right here, 15. And now we still want EB. EB is just this little piece back here, right? Well, it's part of this bigger segment DB. DB is made up of the segments DE and EB put together. How big is dB? 17. How big is DE? 15. So I have 17 equals 15 plus EB. 15 plus what would give me 17? So 2 is equal to EB. So far, so good? Do you guys understand why we had to draw in that radius ourselves? So that we could force it to have a right triangle, because that's what allowed me to use Pythagorean theorem. Let's do number 7 and then we'll call it a day. Number 7, we start off with YZ equals 17. What part of the circle is YZ? That's a diameter. Well, if the diameter is 17, how big is the radius? 8.5, half of that diameter. And then it says UX is 11. What part of the circle is UX? It's a chord. What is the diameter doing to that chord? It's bisecting it. So each section there is half of 11. What's half of 11? 5.5. We know the radius is 8.5. What do they want me to find here? WV and VY. Is WV a radius? No. But what do you notice right there at V? There's a right angle. If I draw in another radius, will I know how big it is? If I draw in another radius, will I know how big it is? Yeah, because we said the radius was 8.5. All radii are going to be 8.5 in this circle. Can I draw a radius in and force it to have a right triangle here? Yes, I'm going to connect W to X, and that segment there would be 8.5. So now I have a right triangle here. So now we're going to use Pythagorean theorem. A squared plus B squared equals C squared. What goes in for C? 8.5, because that's our hypotenuse. We put 5.5 in for either A or for B. I'm going to put it in for B this time, just to kind of do something different. All right, so I have, in the place of A, we're going to replace that with WV. So I have WV squared plus 5.5 squared equals 8.5 squared. What is 5.5 squared? 30.25. And that shouldn't be an equal sign there. Sorry, my pen is really messing up right now. Plus 30.25 equals 8.5 squared. What is 8.5 squared? 72.25. Come on. Okay, hopefully it's working now. So then I'm going to subtract 30.25 from both sides. What is 72.25 minus 30.25? 42. So I have WV squared equals 42. Then we take a square root of both sides. Squared and square root cancel out on the left. What is the square root of 42? 6 point, how much? 6.481. I'm going to write 6.48. So there's one thing we were supposed to find. How do we find Vy? Do I know how big Wy is? How big is Wy? 8.5. Do we know how big WV is? 6.48 plus VY. So then I subtract 6.48 from both sides. And what do I get? 2.02. 2.02 for VY. Homework is due on Friday. You can do all but the last 2 problems on the homework. Have a fantastic rest of your day, everybody.